Let's now consider the consumer's budget constraint graphically. Suppose Tom will spend all of his income in just two goods, books and meals. We can then write this budget constraint in the following way. And if Px and Py are the prices of books and meals respectively, and M represents Tom's income, then Px times X is the income Tom used to buy books, and Py times Y is what he spends in meals. And if we wanted to draw a graphical representation of this budget constraint, again with books along the horizontal axis and meals along the vertical axis, we could simply solve the budget equation for meals, which is a good in the vertical axis. The resulting equation is what we call the budget line. It represents all of the combinations of books and meals Tom can purchase when he uses all of his income to buy them. Notice that the first term is the so-called y-intercept, or the amount of the good in the vertical axis, in this case meals, Tom can buy if he uses all of his income to buy that good. For instance, suppose Tom had a daily income of $200 and that the price of meals was $20. Then the y-intercept will equal 10, which will be the number of meals Tom could buy if he used all of his $200 to purchase meals. In the same way, if the price of books was $10, then the horizontal intercept would equal 20, which will be the maximum number of books Tom could buy if he used all of his $200 to purchase books. Finally, notice that the second term in the budget line equation represents the slope of the line. So any change that changes the ratio of the prices between the two goods changes the slope of the budget line. If the price of the good in the horizontal axis increases relative to the price in the good in the vertical axis, the slope of the budget line will increase. And the slope of the budget line will decrease in absolute terms if there's an increase in the price of the good in the vertical axis relative to the price of the goods in the horizontal axis.